Okay, looking then at algebraic fractions. Okay, so we can do this kind of briefly, I suppose. So an algebraic fraction is fairly, I suppose, in the name, it's a fraction that requires a bit of algebra, a lot of the time a bit of factorizing. So the steps we're going to follow are fairly vague. We're going to complete any calculations in the question. So if there's any sums, anything we have to do, any simplification, anything like that, we're going to start by doing that. Then we're going to factorize the numerator and the denominator. So if there's factorizing to be done, we're going to do that then. And then what we're going to look at is if there's any common factors. And what I mean by that is if there's any factors that are the same on the top and the bottom of the fraction. If we remember, a fraction by definition is division. Okay, a fraction is a way of writing division. So really what we're doing is we're taking an expression and we're dividing it by another expression. So if I have two of the same factors on the top and the bottom of my fraction, what I'm really saying is if I have x plus 4 and I divide by x plus 4, and what's going to happen there is those two factors are actually going to, for want of a better word, kind of cancel each other out. They're dividing in to give me an answer of just 1. And obviously then if I have other factors, 1 multiplied by the other factor, the answer is just the other factor. But just to note, I suppose, that technically what's happening is, say I have x plus 4 on the top here and x plus 4 on the bottom, because that factor is the same, it will divide in evenly and would give me an answer of 1. Okay, so similarly then, if it was x plus 4 times x plus 3, that would really give me 1 times x plus 3, which of course is just x plus 3. So a lot of the time we will kind of use that idea of maybe saying it cancels out because it's common to the top and the bottom, and we are left with whatever's left. So let's just jump through a few of these questions here. We're just going to keep it fairly quick, fairly short here if I can, because really what all that you're doing is you're putting into practice your different types of factorizing. So if you're kind of struggling with that aspect of it, then those are the videos to go back to: your quadratics, your difference of two squares, your highest common factor, all of those videos. Those are the ones to go back to for the real factorizing part of this. All that we're doing now is really that little last step of maybe getting the common factors and kind of eliminating those. So looking at this first example, what I said was, first of all, we're going to simplify anything we can, complete any calculations here. So I can see on the top I have 2x plus 4x, which gives me, of course, 6x altogether. 8 plus 4 gives me a total of 12. On the bottom I have 10x plus 20. Our next step then was to do any sort of factorizing. Now looking at the question there, I don't think there's any quadratics, there's no difference of two squares, there's no grouping, there's only two terms. Grouping we need 4. So I'm thinking highest common factor. So on the top there, I think there's a highest common factor of 3, which is going to leave me with 2x plus 4. Okay, and in fact I'm actually wrong because there's a higher factor of 6, of course, which is just going to leave me with x plus 2. On the bottom then there's a common factor of 10, which leaves me with x plus 2. And now I have a common factor there of x plus 2, which is of course then just going to give me an overall 6 over 10, which reduces to 3 over 5. Looking on the right hand side here, I have two quadratics, so I need to do out these quadratics first of all. Looking at the first quadratic here, the guide number is going to be minus 8, so it's factors of minus 8. So 1 and minus 8, 2 and minus 4, minus 1 and 8, minus 2 and 4. I need factors that will give me minus 2, so it's going to be 2 and minus 4. Okay, using what I did then in the last video there, and if you're not sure, you can follow through the actual factorizing yourself there, but I can actually rewrite my answer then as just x minus 2, x minus 4. Okay, similarly then on the bottom, I need here factors of minus 40. So that's going to be 1 and minus 40, 2 and minus 20, 4 and minus 10, 5 and minus 8. Okay, and am I missing any there? No, I'm not, but I need to continue on. So minus 1 and 40, minus 2 and 20, minus 4 and 10, minus 5 and 8. And again, I want to get a plus 6 in the middle here, so it's going to be the minus 4 and plus 10. So x minus 4 and x plus 10. So I've factorized the top and the bottom part there, and I can now see there's a common factor of x minus 4, which gives me an answer of x plus 2 over x plus 10. As my overall answer. And I can't simplify that down any further because these are expressions. Okay, these are expressions. I can't say, well, there's an x on the top and the bottom. I can't do that because there's a plus between them. Okay, so I can't cancel them out in this case. I have to stop there. So let's just look at a few of these examples here, or a few of these practice questions. We'll not do all of them, but we'll just do one or two just to get a little look at the sort of questions we have here. So let's look at the second one, x squared minus 1 and x squared plus x. So on the top here, it's looking like difference of two squares. On the bottom, it's looking like we'll be doing highest common factor. So the difference of two squares on the top is, so it's x squared, it's x, why is this not working? X squared minus 1, which of course is x all squared minus 1 all squared. So I get x minus 1, x plus 1. And on the bottom, it's x squared plus x, which means I can factor out an x there and get x plus 1. So rewriting now the top and the bottom of my fraction there, it's x plus 1 by x minus 1 all over x times x plus 1. And I can cancel out the x plus 1 there, giving me x minus 1 over x. And as I said before, we can't divide x in there because x minus 1 on the top is a complete expression. So I could only divide something into that if it divided into both parts. So even though, yes, there is an x there, I'm not going to go any further with that one. Okay, the next one again, I'm going to skip down then to this third one here, x squared minus 15, x plus 44, and x squared minus 16. So the top part here is a quadratic with a guide number of 44. So I get 1 and 44, I get 2 and 22, I get 4 and 11, and I obviously also get the minus versions of those, minus 2 and minus 22, and minus 4 and minus 11. If I want to get minus 15 in the middle, it's going to be the minus 4 and minus 11, and again, using what we've been using there, I can reduce that down, solving my quadratic to x minus 4, x minus 11. Same thing then with x squared minus 16, that's a difference of two squares. So it's x squared minus 4 squared, so x minus 4, x plus 4. So rewriting this here, then it gets x minus 4, x minus 11 over x minus 4, x plus 4. I can cancel out the x minus 4, I get x minus 11 over x plus 4. That's my answer for that one, okay? And that's the general idea, really, to all those questions. So there's a few more questions there to practice as well, some more quadratics, but the general idea is the same the whole way along, and it really comes down to the steps we've set up here. Complete any calculations in the question, factorize the numerator, factorize the denominator, and then cancel out any common factors. And if you can simplify it further, simplify it further. Okay, so if there's more simplification that can be done, then absolutely do that more simplification. But for the most part, you would be encountering questions quite similar to those ones there. So it's all about just doing that factorization on the top part and the bottom part nearly separately, and then bringing it all together and seeing, well, what are the common factors that I need to deal with here? And am I able to kind of identify and to cancel those appropriately then?